You sat there the last 2 days, you got everything. In fact, you got it before other people in the class. Aiden, you're this close to being in trouble. Please stop. All right, clear your desk. You can have your resource card, which God forbid if you forgot it, because some of you will not remember these words.
I'll make an extra roll. I don't know what I got, but I think I put up on top of mine. But I don't get it.
All right. The only reminder I want to give you, are you listening, is subtraction. Remember, when you subtract, you must flip all the signs of the second polynomial. Aiden, you're not paying any attention. Do not forget that. The addition, I rarely see people make a mistake on, right? But the subtraction, I'll see plenty of people. All right. Hey, when it says questions 5 through 8, it says name each polynomial by degree and number of terms. I'm looking for that linear trinomial. Well, it won't be a linear trinomial, but a linear binomial. All right. You may begin as soon as there's only 8 questions. You may begin as soon as you get this. Pass these behind you. Hey, cease the talking. Take your quiz. Pass these behind you. 10 minutes. Do 8 questions. It should take you 3 minutes to do them all. All right. Put one sheet of paper in front of you. Pick it. Choose it. Why don't you just use that paper? Do it the smart way. Why don't you just use that paper? I said one piece of paper. Why don't you just use one it's already written on? Right? Apparently I can't count. There's 4. I heard. Ready? Catch. Okay, e-learners, we're taking the quiz. We're going to stay here for 10 minutes, and then we'll start class.
These will all have 2 words on them. Degree and number of terms names. In 1 minute. Anna, Julie, stop. All right, make sure your names are on those. All right. If you were ready for that, then that was the easiest quiz of the year. They don't get much. Listen, please. Listening means you close your mouth. Thank you. If you're ready for that, then that was the easiest test, the easiest quiz of the year. They don't get much easier than that. Homework questions.
Oh, I did it.
Yeah, statements end in periods, questions end in question marks. Yes.
Can you go grab my homework?
Sure. All right, Sierra, turn around. Questions on the homework? Which one?
No, I'm saying
Oh, gotcha.
30.
3-0. You have three things to multiply together. You got a 5, a -3, and a -1. Two negatives turn into, so the answer is positive. 5 times 3 is,
15.
so we're going to have a 15. And then you have some A's and some B's. So it doesn't matter which one you do first. I'll do the A's first. You have an A squared times A to the third. A squared times A to the third. 2 plus 3, A to the 5th power. And then you have your B's. You have a B to the 4th and a B. That means B to the 1st. B to the 4th times B to the 1st gives you B to the 5th, so we get B to the 5th.
Wait, what?
That was 30, 3-0.
So when it's negative variables, like
You just treat it as how many, you got odd or even, right?
The answer would be -15, -8 to the 5th, B to the 5th,
Which number are you talking about?
30.
Yeah, you got two negatives, negative times negatives positive. I just count how many negatives. Hey, I got an even or an odd number of negatives. Okay, I don't even worry about it. And then I put equals, and then I put, well, if it's negative, I immediately put a negative, and I don't ever worry about the negative again. If it's positive, I don't put anything. I don't worry about the negatives again. For me, my mistake I'll make is occasionally I'll drop a negative. So I try to do that first so I don't make that mistake. Sometimes you'll get so, I don't know, entranced or so involved in the multiplication that you can forget, oh, one of them was negative, one was positive, sort of thing. All right, no other questions? Here we go. Grade. Check your work. Okay. Number 2 is A to the 4th. Number 4 is N to the 5th. Number 6 is 30A to the 11th. Number 8 is Y to the 5th, Z to the 4th. If you put Z to the 4th, Y to the 5th, same answer. Number 10, 15, X to the 5th, Y to the 5th. 12, -10, Y to the 7th. 14, -15, R to the 5th, S to the 4th. 16, 12, Y to the 7th, Z to the 3rd. 18, 15, apparently I love 15 today. 18 is 15, A to the 6th, B to the 5th.
And 6s and 5s.
Yeah. 20, -3, R to the 3rd, S to the 6th. 22, 6, A to the 7th. 24, 6, H to the 4th, K to the 7th. 26, 2, C to the 3rd, D to the 3rd. 28, -A to the 6th, B to the 6th. And we already said that 30 was 15, A to the 5th, B to the 5th.
Wasn't it -15 because 5 times negative?
Negative time, there's only two negatives there.
Yeah, but 5 times -3 is -15.
And then times -A. Agree with what you said, Josie.
I thought, but it's a variable. I thought that's.
Yeah, but remember there's always a 1 in front of it, so -1.
Oh.
All right, look at the calendar. Hey, we're done with quizzes and tests for this week. We're going to do 2 new lessons. Listen, please. Hey, it's going to come at you fast and furious this week. Today we're doing something new. Tomorrow something new. Friday something new. Tuesday something new, and then we're going to take our test. This is how Algebra 1 works from now on. Every day something new. Occasionally, when I think it becomes a bit too overwhelming, I will have a review day. But for the most part, every single day it's new stuff. You got to be able to go with that. Okay? It is, for some students, you guys are talking, not listening. For some students, it can become overwhelming. If it becomes overwhelming, I ask you to just take a look inside and ask yourself, was I paying attention in class? Was I doing all the examples? Did I really try to do the homework? During student advisement, was I talking to my friend or was I trying my homework? If it becomes overwhelming because of any one of those reasons, then it's not overwhelming. You're just not doing your job. But but for some students, it can become overwhelming in Algebra 1. So if you get to that point, communication with me is the key. Mr. C, I'm overwhelmed. I did everything you told me to. I'm paying attention in every class. I'm doing all the examples. I'm trying the homework. I'm lost. We can fix that. We can't fix that on Thursday. We can fix that before Thursday. But that requires you to talk to me. Occasionally, I'll see students who get lots of things wrong on homework, -10. And then I'll talk to that student like, hey, you missed 10. What happened? Oh, I figured it out, right? Most of the time, though, either the kid didn't do their homework or they got a -10 and they're like, well, I screwed up on that homework. Let's move on. That's not how you do this. We got to fix those mistakes. That's tutoring. That's asking me questions during the student advisement. You see me every day. I walk in your class. I poke my head in. If nobody says anything, I leave. That's your requirement to stop and say, I need help. It's too late. It's even too late on Wednesday of next week for the most part. Wednesday, we can fix small things, but Thursday, you're taking the test. Okay? By the way, the quarter ends and there's no other time right after that. Okay? All right, come down your homework. These are quickly done. Quickly done. This is not 30 minutes worth of homework. This is 10 minutes worth of homework tops, if you know the rules. For some of you, the rules can become a little bit overwhelming because, well, we had rules from the last class and the class before that, and I still don't know a monomial from a binomial. Well, luckily for you, you can put it on a resource card. That's not the kind of stuff you got to memorize. Nor do you even memorize the rules. What you got to memorize is be able to identify, hey, this is that rule where we add the exponents. Today you get a different rule. Hey, this is that time when we do this to the exponents. Okay? Algebra 1 is definitely a challenging course. Be ready for it. We good? All right, here we go. Powers of monomials. So once again, we're not dealing with binomials, trinomials, polynomials. We're only dealing with monomials today. Yesterday, we multiplied monomials. Today, we do something with their powers. All right. This is called kind of universally, our book calls it this as well, power of a power or power to a power. Either way, I've seen it written both ways. This is what it will visually look like. Typically, not requirement, but typically you'll have parentheses. Inside parentheses, you'll have a number or a variable that is listed to a power, and then that whole darn thing is to another power. This is why this is called power of a power, or power to a power. Okay? Yesterday, we learned the rule for multiplication is do what? Yeah, paradoxically, the rule to multiply is you add. This is going to be the rule of power to a power. Let's see if we can figure out what to do here. I want to say Josie yesterday continually asked me, what about parentheses? What about parentheses? Today we get parentheses. Okay? So let me see. Well, I know that a power is showing repeated multiplication. So I got a 3 on the outside. What is being repeatedly multiplied, Chris?
The exponent.
Okay. What is being repeatedly multiplied is the thing that's attached to the power. What is attached to the third power here? And it's more than that. It's you said it right the first time. It's the parentheses 4 to the second power. Can you see this? Julie, you're not paying attention. Okay. What's to the power here? It's the parentheses that are raised to the third power. So remember, you have the base and you have the power. The power tells you how many times to write the base. So what's the base here?
4 to the second.
More than that. Parentheses 4 to the second. So I'm going to write parentheses 4 to the second how many times? I'm going to write that 3 times. Well, 4 to the second is technically 4 times 4, yes? So I'm going to choose, you'll see why here in a second. To write 4 to the second is 4 times 4. So I need to write parentheses 4 times 4 3 times. Hey, Guess what now is being repeatedly multiplied here? There's just 4s. They're all being repeatedly multiplied. Hey, how many 4s do we have here? 1, 2, 3, 4, 5, 6. So the answer is, so you tell me, if that's the start and that's the finish, what did I really just do, Chris? It looks and it appears that all you do is multiply the powers. That's the rule. So, 2 things. This can easily be confused with yesterday's class. What did we do with the exponents yesterday? Today we're gonna, boy, this can cause confusion. Yesterday's class we added the powers. Now we're gonna multiply the powers. Write this down, box 1. Okay, box number 1. It's called the power to a power rule. If you have something raised to a power, raised to another power. Oh, by the way, this can continue on and on and on. Okay? But Algebra 1, you only see it done once. If you have something to a power raised to a different power, you multiply the powers. Chris?
And what we just did before was that
And we're going to be simplifying today as well, too.
that was.
Yes.
Okay, cool. All right.
So when it says in homework, it says to simplify, this is what it means.
All right, cool.
Okay. Can anyone see where the confusion begins?
No.
What did we do yesterday with the powers? What are we doing today? So you have to know, when do I add, when do I multiply? For me, it's a visual thing. Hey, I got a power raised to a power, I multiply. There's no dots here. There's no parentheses times parentheses. Yesterday, last night for homework, you had a parentheses and then another parentheses. That's multiplication. Or maybe you had something, dot something. And the irony of it is, when you multiply, you don't multiply, you add. That's the other thing that causes people conniptions, right? I don't have anyone that has problems with the multiplication or the addition, but I have plenty of people, when they look at this, they're like, I don't remember if this is a multiply or an add one. Okay? Powers to a power you multiply, multiply you add. And I realize that just sounds really horrible. There's just a lot of words there and they kind of jumble all together. Power to a power you multiply, multiply you add. Those are the 2 separate rules. It is what it is, you got to deal with it. Okay, but the cool thing is that if you can identify what to do, it's just pretty simple. You're either going to be adding or you're going to be multiplying. Hey, today, the hardest ones we do, you're going to be doing both. We'll get to that later. All right. Hey, power to a power, what do? I rewrite the base and I multiply the exponent. So what's the answer? There's nothing challenging here if you know the rule. The challenging part is to realize this is the one that we multiply. Contrast that with when we add. 4 to the 5th times 4 to the 6th. What do we do on this one? What do we do on this one? So what's the answer? We never multiply the base, Julie. That's the thing that we said we would not do yesterday. What's the answer on this one? 4 to the 11th power. Can you see why this is confusing? This one you add, this one you multiply. You got to be able to visually identify, wait, is that the one that we add? Is that the one we multiply? You're not panicking yet? I would be. This is hard to differentiate. How do you know which one we're doing? Typically, you could say the ones with the parentheses. Now I'll make it challenging. This is what you had last night for homework. Now what? It's still the same, but they got parentheses, so you can't. Exponent inside, so is there here. So that's what you got to be able to do. I can't help you with that other than showing you the 2 examples and saying add, multiply. You got to be able to wrap your head around the differences. Some people do it like Sierra. She's saying, oh, I can see the power is raised to a power. Other people look at both of these and are like, I'm confused. Okay? All right. What's the answer here? Okay. What's the answer here? There's how you're going to see the difference between the two. This one has a dot, but it might not. It might have parentheses. It's still a to the 8th, and this one is a to the 12th. You got to be able to identify. Why? We get to quiz, or we get to test day. It's going to be a combination of everything thrown in. If you can't identify which one do we add, which one we multiply, things go wrong very quickly. All right, box 2. Can you do that by yourself? Easy or hard skill? As long as I restrict it to just one of them, everyone gets it right. As soon as I group them together, hey, some adding, some multiplying, people will get these wrong immediately. It gets way more complicated. These are the easy ones. Anybody need help for these? Okay, is this a power to a power? What's the rule for power to a power? What? Multiplying. The hard thing to do is, this is the other way it will be written. This one is you add, this is the one that you multiply. This is the one that you add, this is the one that you multiply.
Do we have?
Oh, I'm going to show you both. Yeah, that's how we end. Sorry. Right there. That's a combination of both. If you want to see what a combination of both looks like, look at box 4. That's a combination of both. All right, Haley, first one, what's the answer? Tell me what to do. I'll do the math for you. Okay, so x to the 60th. Good job. All right. Harley, second one? Yeah. No, what you said, 3 to the... Okay, we got this? All right, those are the easy ones. Do we need to do more? We got this. All right, I'm going to move on to the more difficult. But what I do want to point out is that you can visually identify the difference of when you're multiplying and when you're adding. This one you're adding, this one you're multiplying. This one you're, this one you're adding, this one you're multiplying. This was last night's homework, yes. This is tonight's homework. The reason why I'm doing it like this is because after today, you're going to see both of them put together. And you have to know, be able to visually identify, when do I multiply, when do I add? All right, p to the 30th and 10 to the, that's a big number. That's 150 zeros, by the way. Your calculator will, blue smoke will come out of it if you type that in right now. All right. All right, so these are the more challenging ones. Here comes the more challenging ones. So this is a combination of the two rules. You ready? Is there any power to a power here?
Yes.
Which one? Can you see that this one, the one on the right, is power to a power?
Yes.
Does this 2 go to this 3? No. So you do power to a power first. So what does this give me?
C to the 10th power.
So I'm going to erase this and write what? So that's power to power. But what's this? This is one of those adding ones. So the final answer is, you got to tell me, can you visually see what just happened there? Okay. It's not that hard, but it certainly can be confusing. So the key to that is we do a bunch of them. And we do practice, and we do homework. And we do the homework tomorrow when we call out the answers, we pay attention. And we get one wrong, we look at it. We don't just, on some of your papers, you just don't just write the answers. Because when you just have the answers on your homework and you get it wrong, you're like, whoop, got that one wrong. If you have the question written next to your, I'm complaining you probably can't do this whole thing in your head. I would like you to see the individual steps. But if you have the question and the answer, you can kind of ascertain where you made your mistake from. But if all you have is the answer and it's wrong, you're kind of guessing what the mistake was. All right, Aiden. What are we going to do first here? Okay, you always do power to a power first, which is which is,
or 8.
so I'm going to cross through this and write what?
I was adding 8.
Okay, so I'm going to write x to the 5th times x to the 8th, yes? Okay, now what? Is this a power to a power?
Yeah, so you got times.
Is it a power to a power?
Yeah.
Where do you see a power to a power?
No, it's not.
This is yesterday's homework. So now what do we do?
5 times 8.
That's today's homework.
That's
This is yesterday's homework, last night.
Got it.
So what do you do with the powers?
14.
Okay, close, it's 13. Okay. It can be easily mistaken, yes.
I was on here. Have you seen it?
Which one?
My water bottle. It's blue with a dark blue.
The only cure for this is doing more. Let's do some more. All right, this is box 4. Box 4. Lots of stuff going on here. Lots of stuff. Okay, Nathan, do you see any power to a power there? Yeah. How many? Nathan sees 2 powers to a power. So you got to do the power to a power first. What's this one? The part on the left turn into? What's the one on the right turn into? So he said that turns into that. Can you see that? Where he gets that from? 100%. Good job, Nathan. Oh, Nathan, now what do we do? So therefore, you would have pooped your pants if I shown you this on day 1. You just killed that one, right? You applied the rules correctly. Good job. This is Algebra 1, by the way. We don't teach this to pre-algebra, so this is Algebra 1. Okay. Cool? And I'm going to say it as I always say in Algebra 1, right? I'm going to show you something that on the face value of it, right, looks complicated, and I teach the rules, and you're like, okay, this is easy. It is easy, but you got to get to that point. And sometimes getting to where, oh, this is easy, takes a lot of effort. And everyone has a different level of that. Some people get it in 5 seconds. Some people get it after 5 examples. Some people get it after my 3rd word of my sentence. This is what you need. Okay, I got it. Everyone's somewhere on that continuum, right? Some people can get this like that. Other people require a bunch of examples. Think about this. If I take that and raise it to the 4th power, that turns into, okay, well, that's easy. Kind of feels like we're sort of doing a distributive property. We're kind of distributing this 4 to the power on the inside, yes? Kind of see that? Oh, by the way, this is not the distributive property, but it kind of has that feeling for it. So what would happen if I didn't have one thing on the inside? I had multiple things on the inside, like that. Okay, anybody want to take a guess what we got to do? Kaylee? Well, we certainly do 5 times 4, but what happened to a to the 3rd power? Is it raised to the 5th power?
Yeah.
It's on the inside of the parentheses. So this is why it kind of has the feeling or the flavor of distributive property. So when you have parentheses and you have a power on the outside, guess what you got to do with this power? You got to give it to every exponent on the inside. Notice what I said. I didn't say one thing. You got to give it to every exponent on the inside. And when I say give it, I mean multiply. Yeah.
So would it be A15, B20?
So if I give it to everything, how many arrows am I going to have? 2, because there's 2 exponents. So that's going to give me b to the,
20.
and that's going to give me,
A to the 15.
so the final answer, Sierra, is? So the final answer is a to the 15th, b to the 20th. Okay? This seems like a simple thing, but it can get a little messy when there are negatives involved. So you got to be ready for negatives as well, too. But let's do positives and make sure we all got this. Okay? I got something raised to the 3rd power. Everything on the inside is raised to the 3rd power. Go ahead, Chris.
2 times 3, 6, and then 6 times 3,
18. Now tell me what the final answer would be then.
right.
Tell me what to write.
Right. RT. No.
You said it right.
Yeah. RT to 6.
R to the,
R to the 6 and T to the 18.
there you go.
And then we would.
No. You cannot measure it. You can't multiply R times T because what did we say yesterday? Are you allowed to multiply variables that do not have the same letter?
No.
You're not. So we could not multiply these together. If they both were R, then you would be right. Then we could, add them. Questions? All right, let's do a couple more with positives before we get to negative. All right, here's another hard one. I said that this 3 has to go to what? One thing or all the exponents? How many exponents are on the inside?
2.
I got 1 and I got 2. Which one is it?
2.
Oh, now everyone's going to agree it's 2? So what are the 2 powers? What are the 2 powers? Where's a 0?
No, it's got a 1 in front of the 2.
Oh, it's got a 1 and a 4. Okay? Remember, when there's a integer or a whole number, that number is raised to the first power. So, Rowan, what's the final answer here?
Yes.
Absolutely wrong. When there's a power on the outside of the parentheses, what do you do with the power and the exponents on the inside? Everything. Therefore, it can't be 3t to the 12th. It must be, did you multiply all the powers? What's 3 to what power? So what do we got to do with the 1? So therefore, you don't get 3, you get 3 to the, this 3 right here has to go to every power. Every power on the inside. Therefore, the final answer is 2 to the 12th. So that 3 needs to go to every power. Now, the book will probably, if you do check your answers, and I gave you odds, which I didn't, the book will never write 3 to the 3rd. They'll go ahead and tell you what that number is, 81, right? I'm sorry, 27. They can 3 to the 4th. So they would probably write 27 t to the 12th power. I'm okay with 3 to the 3rd. All right, but the book would probably write that. Who's lost? When everything's positive, things are good. We do have to start talking about negatives after this. All right, do box 5, please.
Would it be
Who's struggling and needs some help? Well, we're not there yet. Yep, that's right. Yeah, but if that's the answer, then how did it? Okay, I'm with you. I'm with you. You're actually correct. So
would it be 9 to?
That 5 has to go to everything. Oh, 9. Yes. I thought you said 9 to the first. That's good. That's good. Good work. You good? Over here? All right, you got this?
No, I never did that.
Which one? Oh. What is that? Not that. You're going to do each one individually in the right way. So 5 times 2 is 10, and then 5 times what's the power on the 9? What's the original power of the 9?
Sure.
Where's its power? Is there a power there? Or 1? No, well, 1. Now multiplying you get. And this one is. All right, so I checked a couple people. They all got it. First one, Kristen, what you got?
I got 9 to the 5th and x to the 10th.
9 to the 5th, x to the 10th. Good work there. Landon, second one.
2 to the 12th and z to the 8th.
All right, nothing really challenging there, correct? When everything's positive, I usually get everybody gets it right. And listen, please. As soon as I throw negatives, the wheels fall off. So we got to do some ones that have negatives. So you got to be crazy careful. Get it? Be careful. You got to be crazy careful when there's negatives. We've seen this before. We even have a rule for it. Brandy, do you remember the rule with negatives and powers? Who remembers the rule for negatives and powers? Rule for negatives and powers. What's the rule? What do you got? Josie, I know you remember this.
What?
What's the rule for negatives and powers? I believe you were the one that came up with the rule, by the way.
Putting me on the spot. I don't know how to say it in
If
words.
the power is odd, the answer is always.
A negative. Oh my god, I can speak.
If the power is even, the answer is always positive.
I was right.
Here's the reason.
I said
If you have two negatives, when you multiply them, the answer is always
positive.
So I don't care how many you have, if there's an
Always
even number of them, well, this always results in positive, positive, positive. As soon as you have an odd number, great, these two make it positive, but you've got that one last one that flips the whole thing negative. So the rule that no one remembered, right, is that when you have a power and you have what's on the inside that is negative, you don't need to worry about whether the answer is negative or positive. You just read the power. If the power is odd, the answer is negative. If the power is even, then the answer is positive. Please stop over there and pay attention. All right. Okay. The rest of it is how you would expect, right? That 5 needs to go to every power on the inside. So that's going to be something to the 5th power. And that's going to be, well, that's also to the 1st. That's going to be something to the 5th. Then we apply that rule that if the power is odd, the answer is negative. So it's going to be negative whatever to the 5th. Let's see, let's count by 2s. 2 times 2 is 2 times 2 is we're multiplying by 2s. 2 times 2 is
4. 8.
8.
I'm saying 6.
We're multiplying by 2.
9.
One more time. 2 times 2 is
4. 8. 16. 32.
Why do I have 5 fingers up?
Because it's the 5th
It's to the 5th power. That's how you do 2s. But we said the answer is negative, so the answer is negative 16. Okay? So this is the odd even rule, right? So why did I put 32? 4, 8. Oh, it is 32. What did I say 16 for? Okay. 32. Questions? Okay. Aiden, do I need to call on you to ask you, did you understand this? Okay. So you tell me the rule. When the power is odd, what's the answer? Always. What? You said it backwards. So my suggestion, start making a resource card, right? That's clearly one of the things. The other 2 things that you probably need on it are examples, Tristan. Are examples of when do you add and when do you multiply. Power to power, you multiply, you add. Tomorrow we get some more rules. The next day we get some more rules. Monday or Tuesday we get some more rules. And then we take a test. It's too late next Wednesday when we take the test, or Thursday, whatever the day was, to try to fix those mistakes. All right.
That hurts.
One more. Okay, you tell me, is the answer going to be,
Negative 4 to this.
is it going to be negative or positive?
Positive.
How do you know?
That's got 2.
Now you got to be careful. Look up here. You got to be careful. Don't assume because this is even that the answer is positive. Because what we have to do is we have to look at that power as well and do that multiplication first. 2 times 1 is 2. But if this number was a 3, would the answer be positive or negative?
Negative.
Positive.
6 is even, so it's still positive. The point being, as I'm saying, don't assume that you can tell from the power on the outside. You need to look at the product of the 2 powers first before you determine whether it's odd or even. Okay? All right. And that's what will happen in the next example after this. All right. So if we distribute that 2, we're really not distributing, Tristan. We're really not distributing the 2. We're really taking powers to a power. So that 2 needs to go to every power on the inside. Well, negative 4 is to the 1st power. So 1 times 2 is 2, 3 times 2 is 6. Now is when you can apply that odd even rule. Now you can say with confidence that, oh, it is, say it. It is even, therefore the answer is positive. Hey, I have 3 people in the entire class that are with me. Everyone else, your attention is not where it needs to be. The summer, when you're in summer school, right, because you didn't give me the attention that you needed to, and you didn't pass Algebra 1, I'm going to be on the golf course. I will not be teaching you Algebra 1. You enjoy your Algebra 1 in summer. As a motivation to you, that's a motivation speech, hopefully, or a demotivation speech, right? When I see that you're not paying attention, and I know this is what you'll make mistakes on, please give me the benefit of the doubt of I know what I'm doing. When I see that your attention is 0 on the stuff that this is where students make a mistake, I will stop, and I will give you a speech, or at least try to redirect your attention. You can pass Algebra 1, but you can't pass it if you don't try, you don't pay attention. Some of you are not paying attention or trying. All right, let's do this one together. Box 6. Here we go. Box 6. Step number 1. Hey, powers to a power. Take the 3 on the outside, give it to every power on the inside. Hey, why is the pencil not in your hand, Aiden? Right, you should, because you got this one wrong. Let's do this. Here we go. All right, here we go. 3 is to what power right now? To the first. So 3 times 1 is? 3 times 1 is 3. Hey, 3 times 3 is?
5.
That's the easy part.
5.
Now we look at the odd even rule.
My mind.
Hey, odd or even? Therefore, the answer is, why? Come on, we're not done.
That was the first bell. There's one more bell.
No, there's 2
That
minutes.
was our
No, that was the first bell.
That was the second bell.
Well, okay, I'm talking about lunch bells. That's the first lunch bell. Right? All right, for you guys, it's the first lunch bell. So you got 2 more minutes. I know what you meant by second lunch bell. All right, hey, now we can apply the rule. Haley, if you can tell me the rule, I will stop talking and let you go, the entire class.
Haley, come on, come on, come on, come on.
You can tell me the rule.
Please, Haley. Someone help her.
Haley, tell me the rule.
Like, I know it's like the negative one.
It is, so tell me the rule. Hey, now I gave you the chance and you said it backwards. Haley, you have to know the rules. And I did ask you to write it down before as well. If the number is odd, the answer is? If the power is odd, then the answer is negative. Now, I do want to make one slight change.
Or as I say,
Look
odd
up
is
here.
bad.
I'm getting my full 2 minutes worth because they only couldn't give you the answer. Look up here. Does the rule apply if that was a positive 3?
No.
Good. For those of you paying, that was half of you. If it's a positive number, we don't even consider odd or even. We only consider odd or even if if the number on the inside parenthesis is negative. All right, for the rest of you guys that were paying attention, answer positive or negative.
Positive.
It's negative. Okay. Why? Because this is an odd number. Okay. So negative 27. Like I said, the book will probably write that out. All right.
Let me ask
The last thing of the day is this. Sierra looked at this and she kind of figured it out herself. All right, turn around, Sierra. So evaluate. They're going to give you a power to power expression. They're going to give you values to plug in. You just need to be careful when the thing that you're plugging in is negative. When the thing that you're plugging in is negative, you need to add parentheses. All right, let's plug it in. What would it say when I plug in a 2?
4 times 2.
Can you do 4 times 2 before you raise it to a power? You can't because it's inside parentheses. PEMDAS says do parentheses first. So if you want to, you could have done 4 times 2. 4 times 2 is 8, and then 8 to the 3rd power. If not, then do it the other way, which is distribute the 3 to everything on the inside, and then plug in your value. 4 to the third power is 64. It tells us that t is 2. 2 to the third power, 2 times 2 times 2 is, you're going to get large numbers tonight for homework. Who's lost on what I just did? Positive numbers. Negative numbers cause problems. Notice I didn't give you negative numbers. Okay? Tonight for homework, you have a combination of positive and negative numbers. All right, go to lunch.
Was I doing good?
I'm just concerned that you don't retain any. In the last 3 days of class, you've done really well in class. You've gotten it every single time. But I looked at the quiz and you got every one wrong, right? So my concern is you're not retaining any of the stuff.
Yep, of course you're right.
Hey,
Nice, 130.
All right, e-learners, any questions? No? All right, I'll let you guys go and see you tomorrow.